All right, so today we're going to be doing mean absolute deviation. Mean absolute deviation is basically find the mean, find the difference, and find the mean of that. It just helps you find variability, and we'll discuss that further. Sometimes I call mean absolute deviation MAD, just to let you know. So the first one, I gave you a set number or a data set, and I want you to calculate the mean. So the way you calculate the mean is you add all those numbers together and divide by the numbers, divide by the count of the numbers. So you're going to do 60 plus 58 plus 54 plus 56 plus 63 plus 65. I'm doing this on a calculator. Plus 62 plus 59 plus 56 plus 58. When you do that, you get 591. So 591 is not your mean, but is a number that you divide. So since there's 10 numbers, you'll divide it by 10, which is 59.1. It says round to the nearest whole number. So round to the nearest whole number would be 59. So that's my mean. Next, it says complete the table. So it says the distance from the mean. So the distance from the mean, what I would do is I would subtract. So this one, I would do 60 minus 59, and I get 1. This one, I would do 58 minus 59, and you would get negative 1. But since I'm just trying to find the distance, it would be an absolute value, so it would just be 1. So 54 from 59 is 5, 3, 4, 6, 3, 0, 3, 1. So this is what I would call my difference. So this is my difference, and what I would do is I would add these up again and find the mean. So you do 1 plus 5 plus 3 plus 4 plus 6 plus 3 plus 0 plus 3 plus 1. And you would divide, so then you get 27. But that's not your mean, okay? Your mean would generally be around the same range of your numbers. So since there's 10 numbers again, you divide it by 10. So 27 divided by 10 is 2.7, but it says round to the nearest whole number. You round it up and you get 3. And that is how you find mean absolute deviation. Okay, try another one. So again, they gave me a set of numbers. So we're going to find the mean. So you're going to do 46 plus 47 plus 56 plus 48 plus 46 plus 52 plus 57 plus 52 plus 45. So you get 449. Now there's only 9 numbers. So you're going to divide it by 9. Oops. And you get 49.88 repeating, which rounds up to 50. So 50 will be my mean. So now we have to find the difference between the data set and my mean. So 46 minus 50 is 4, but you have to find the absolute value of it. So that'd be 3, 6, 2, 4, 2, oops, yep. I think that's supposed to be 7, actually, not a 3. 7, 2, 5. So you add them up. So you do 4 plus 3 plus 6 plus 2 plus 4 plus 2 plus 7 plus 2 plus 5. And then you get 35. So then you take that number and divide it by 9. And you get 3.88 repeating, which rounds up to 4. Hey, let's do another one. A chicken farmer, wants her chickens to have all about the same weight. She is trying 2 types of feed to see what type produces the best results. All the chickens in pen A are fed premium growth feed. All the chickens in pen B are fed maximum growth feed. The farmer records the weights of the chickens in each pen in the tables below. Which chicken feed produces a less variability in weight? So we want to find the less variability, and I'll explain that after we find our numbers. So first off, when it asks you for the variability, it's really trying to figure out the MAD, the mean absolute deviation. So we have 2 pens, pen A and pen B. So I'm going to do pen A first. And I gave you this little chart to help you organize your numbers. So we're going to list out the numbers here. So now what we're going to do is we're going to take these numbers. You're going to do 5.8 plus 6.1 plus 5.5 plus 6.6 plus 7.3 plus 5.9 plus 6.3 plus 5.7 plus 6.8 plus 7.1. So then you get 63.1. But again, that's not your mean because you have to divide by the numbers you have. So there's 10 numbers. You divide by 10. So that'd be 6.31. And since it doesn't say to round to the nearest whole number, I'm just going to leave that as my mean. So 6.31 will go in this column. I'm just going to draw an arrow. And what you're going to do is you're going to subtract. So I'm going to do 5.8 minus 6.31. And you get negative 0.51. But it needs to be the absolute value. So it would just be 0.51. So then 6.1 minus 6.31, 0.21. 5.5 minus 6.31, 0.81. 6.6 minus 6.31 will be 0.29. 7.3 minus 6.31, 0.99. 5.9 minus 6.31, 6.3 minus 6.31, 5.7 minus 6.31, 6.8.
You're being signed out. Nathan Conahan, you're being signed out.
7.1 minus 6.31. So now, since I have my distances from my mean, what I'm going to do is I'm going to average them together. So you're going to do 0.51 plus 0.21 plus 0.81, 0.29, 0.99, 0.41, 0.01, 0.61, 0.49, 0.79. And you get a sum of 5.12. But then you have to divide it by 10 because that's your count. You get 0.512. So that is my variability, or in this term, MAD. So let's do pin B. So we're going to add them up. And you get 66.9. Since there's 10 numbers again, you divide by 10, and you get 6.69. So 6.69 goes right here. And then you subtract it. Oops. That'd be 0.41. 5.4 minus 6.69, 1.29. 7.8 minus 6.69, 1.11. 6.1 minus 6.69, 0.59. 5.2 minus 6.69, 1.49. 7.5 minus 6.69, 0.81. 7.9 minus 6.69, 1.21. 6.3 minus 6.69, 0.39. 5.6 minus 6.69, 1.09. So now we're going to add them up. 1.01 plus 0.41 plus 1.29 plus 1.11 plus 0.59 plus 1.49 plus 0.81 plus 1.21 plus 0.39 plus 1.09. When you do that, you get 9.4. But then you have to divide by 10, and you get 0.94. So pin A was 0.512, and then pin B was 0.94. So pin A will have the less variability. Okay. What I mean by that, she wants to have the chickens all weigh the same amount. They don't want to be huge differences. So pin A shows it has less variability. Basically, it shows that the numbers are closer together with each other. There's a variability of 0.512, while here there's almost a variability of 1, which is actually a pretty big variability. Okay, that's how you find mean absolute deviation. If you need extra practice or need extra help, just let me know. Thank you, guys.